This is Jim Williams with the Hurricane City Tropical Update for July 19th, 2:30 p.m. This is a remake of an earlier tropical video from this morning. We had some volume issues, so I'm going to redo this video for the viewers out there. First of all, things are quiet in the tropics, but back in 1997 we had Hurricane Danny approaching the northern Gulf Coast as a Category 1 hurricane, and this very slow-moving hurricane dumped a bunch of rain in Alabama, up to 40 inches in some locations. But luckily, there's nothing like that going on right now in the Atlantic Basin, and the primary reason for that is upper level wind shear. Here's the SIMS map, and we have this long swath of upper level winds out of the west and northwest, upwards of 30 and 40 knots, and that is due to the fact that we have several upper level lows out in the Atlantic. So that, in combination with the fact that we have a lot of dry air out in the open Atlantic, is preventing any development, and most of the models now are indicating we're not going to see any development for at least a week or so. So things should be quiet for a little while. Let me go ahead and show you a water vapor loop of our systems out here swirling around, mainly upper level lows, and you can see we have quite a few swirls. In fact, if this keeps up, I'm going to have to change the name of Hurricane City to Upper Level Low City because of how many upper level lows are out there. But let's count them here. We have one in the Bahamas. We have another one here in the southern Gulf of Mexico. We have this one up here in North Florida. We have another swirl up here near Bermuda. And we have another out in the open Atlantic. And this may be the beginnings of yet another one out here in the open Atlantic. So that's 1, 2, 3, 4, 5, 6 upper level lows. And that's basically what's called a tropical upper tropospheric trough. Try saying that 10 times in a row. But that is what's happening. We have deep troughs out here with upper level lows, and that's very unfavorable for development in the Atlantic Basin. So it's going to remain quiet for a while. So I wanted to use this update video to talk a little bit about hurricane history for the models. Going back to 1992, when Andrew was out in the Atlantic, that was an El Nino year, and we didn't have a whole lot of models to go by. In fact, there was only a handful of models, and here they are right here. And the aviation model, which is now known as the GFS, was the best performer throughout that 1992 hurricane season, averaging about 96 miles off on systems at 36 hours and 116 miles off 48 hours. Now, back then, they did not go out 5 days on the forecast. If they did do that, it was kept private from the public, and they did that behind the scenes. But publicly, this was the best performing model, was the aviation model, which is now known as the GFS. Now, here we have the 2000 hurricane season, and even back in 2000, there wasn't a whole heck of a lot of models to go by, but the GFDL was by far the best performer. It's at 3 days and 5 days. And if we skip ahead to 2004, this was the very active hurricane season where Florida was hit a whole bunch of times. The AEMN model was the best performing model, which is basically the GFS mean ensemble model. And the GFSO, the GFS operational models, was the best performer during the 2004 hurricane seasons. Now, at the end of this update video, I'll show you what this all means in a graphical format as far as the best performers overall. But back in 2005, this was the write-up from the National Hurricane Center to conclude the 2005 hurricane season, that the GUNA model was the best performing model overall. And this is a consensus model that uses the AVNI, the GHMI, the EGRI model, and the NOGAPS model. Interpolated. All these are interpolated models, which means they grab all these models together with additional information and put them all into one and come up with a forecast for a model. So the GUNA model was the best performer in 2005. As far as tropical models are concerned, the GFDL was the best for shorter range track forecasts. The UK Met and the BAM models were both also strong performers in the Atlantic Basin for the 2005 season. And here's graphically what happened in 2005. The best performer at 36 hours was the Florida State Super Ensemble model, and the best performer for a week out was the GUNA model, which again is the consensus of the AVNI, the GHMI, the EGRI, and the NGPI models. Here we are in 2006. The GFDL was the best performer at 36 hours, and the AEMN again at 120 hours. Here we are in 2007. The EGRI, which is the UK Met model, was the best at 36 hours. The GFS interpolated model was the best at 5 days out. Here we are in 2008. The EMXI was the best performer at 24 hours. as well as 36 hours out, and the Florida State Super Ensemble model was the best at 5 days. Go to 2009, the Florida State Super Ensemble model was the best at 36 hours, and the CMC, which is the Canadian Interpolated model, was the best at 5 days. And 2010, the EMXI, 36 hours, the EGRI at best at 5 days. And then we have the last year's models, the TVCA model, which is a combination of the AVN, the UK Met, the NOGAPS, and the HWFI model was the best performer overall. And then the EMXI was the best at 5 days out. So what does this all mean? Well, let's take a look at what happened over the all the years. If you take the best, say the best 5 or 6 years here, we're going since 2004, and I added up all the models that were the best at 36 hours. And the reason I like to use 36 hours is because, quite frankly, 36 hours is when you know that for sure. If you're within that cone in 36 hours, you're going to get something out of it. And at 120 hours, that's just important because that's going out in the future to see which model performs best over a 5-day period. And I took all these and added them up. The one that shows up the most is the EMXI between the 36 and 120 hour forecast. And that's basically the European model with interpolated data added into it. And that's basically an adjusted interpolated dynamical model. And that's the European interpolated is the best overall of all the models over the past few years, but only just by a smidgen. The second best is the EGRI, which is the UK Met model, adjusted the same way. And then number 3 is the Florida State Super Ensemble model, and that is the third best out of all the models. Now, when you look at this text here on the screen, it's showing all these models. A lot of these models you may see on the model maps on the front page of Hurricane City when there's an active system. That tracking map on the front page of Hurricane City will show the 5 best performing models. Oftentimes you'll see some of these models mixed in with it. Sometimes they're the interpolated models, sometimes they're the regular models, but the one model that will not show up on there is the European model, which is the EMX model, because the European information is unable to be ingested into the model data that we use, the KML file, so we do not have the EMXI and as well as the Florida State Super Ensemble model are not able to be displayed, which is unfortunate because those are 2 out of the best 3 performing models. But with that said, this past season, this hurricane season, Tropical Storm Debby in the northeast Gulf of Mexico, the GFS interpolated models performed the best, indicating this was going to continue to move northeast into the Florida Panhandle, whereas the EMXI model, which is one of the best over the past several years, had it going into Texas and then Louisiana. So the models of interpolated models of the GFS have done very well this year because they've made some adjustments to those models. So pay attention to the front page of Hurricane City when there's a system out there and pick the 5 best performing models. There's a pretty good chance that the system is going to go the direction of those models at Hurricane City. Anyway, that's a little tutorial on what's happened the past several years with the model. The European model's been the best, followed by the UK Met, and then the FSU Super Ensemble model. Some of those do not display on the map at Hurricane City, but just a general guidance for you to use. Anyway, that's about it for now. I'll be back in a few days if things change in the tropics. And again, I apologize for the earlier video. We had some connectivity issues and volume issues. Hope this one works out okay. Look forward to your feedback. Thank you again for visiting Hurricane City.